China has just taken a major leap in autonomous aviation. The CH-7, a next-generation unmanned stealth aircraft, has officially completed its first flight. This isn't a concept model or a test mock-up. This is a fully airborne system that could reshape long-range aerospace missions. Today, we're breaking down what the CH-7 really is, how China managed to bring it to the sky, and why its capabilities are attracting global attention. The CH-7's first confirmed flight represents the moment an advanced aviation program transitions from theory into reality. After months of runway activity and static evaluations, China released clear footage showing the CH-7 airborne for the first time. This single milestone signals that the aircraft has entered the crucial stage of flight testing, where engineers gather real aerodynamic data and validate stealth shaping under operational conditions. To appreciate why this is important, we need to understand what the CH-7 is designed to do. The aircraft was developed by the China Aerospace Science and Technology Corporation's 11th Research Institute. It uses a flying wing architecture, similar in spirit to other stealth platforms, with smooth, blended edges and a broad wingspan of roughly 26 meters. This layout supports reduced radar visibility, high aerodynamic efficiency, and large internal volume. Unlike traditional aircraft, the CH-7 has no cockpit, canopy, or need for pilot support systems. Removing those structures frees internal space for fuel and equipment, helping the shape remain sleek and uninterrupted. Its dimensions place it between a conventional medium-altitude drone and a full-size strategic aircraft. However, the CH-7's design suggests that its performance could exceed that of older manned aircraft with similar wingspans. Without pilot requirements, the aircraft can remain airborne longer, fly higher, and operate in areas too demanding for human crews. Its airframe also appears capable of carrying precision-guided equipment internally. One of the most intriguing details is that the CH-7 version seen in flight testing features vertical stabilizers, angled outward, rather than the entirely tailless configuration shown in early concept displays. This refinement indicates an evolution from a showroom model to a more practical aerodynamic design. Engineers likely added these surfaces to enhance low-speed stability, improve turn coordination, and achieve smoother handling during long-endurance missions. The significance of the first flight goes beyond the visuals. A flight test demonstrates engine reliability, flight control maturity, structural endurance, and stealth profile stability across multiple phases of flight. Every moment in the sky generates telemetry that helps engineers fine-tune the aircraft for future tasks. The CH-7's development becomes even more significant when viewed within the broader strategy now emerging inside China's aerospace community. The CH-7 appears to be only one component of a multi-tiered family of autonomous, stealth-capable aircraft, including a much larger and more powerful unmanned system that has already begun its own early testing. This heavier aircraft, first spotted in satellite imagery, reportedly has a wingspan exceeding that of some modern strategic platforms. The scale alone suggests an emphasis on extended range operations, large internal volumes, and multi-mission flexibility. While specific details about this larger model remain limited, its existence reveals that China is not limiting its ambitions to a single stealth drone. Instead, it is constructing an entire ecosystem of autonomous aircraft, each filling different roles across a wide operational range. Understanding the CH-7 within this context changes the picture entirely. Rather than being a standalone project, the CH-7 functions as the medium tier of a broader system. It fits between smaller reconnaissance drones and the newly observable large-scale platform. This approach resembles how some nations develop layered satellite constellations. Lightweight satellites handle routine jobs, while heavy-lift platforms support more demanding missions. By mirroring this idea in the air, China can create a more adaptable and resilient aerial network. The CH-7's size suggests roles involving long-endurance intelligence collection, over-the-horizon sensing, and precision delivery of specialized equipment. Meanwhile, the larger aircraft appears designed for extremely long-range missions. Together, these platforms can operate in coordinated formations, share data autonomously, and function as part of a broader sensor grid. This layered strategy also demonstrates confidence in automation. Developing autonomous aircraft capable of long-endurance flights means entrusting complex decisions to advanced onboard systems. It suggests maturing artificial intelligence frameworks, more reliable engines, improved composite structures, and advanced digital flight control architectures. Just as space exploration relies on autonomous probes operating far beyond human reach, these aircraft show a shift toward high-end aviation systems that don't require human presence on board. This marks a growing philosophical shift in aerospace design. Eliminating human limits opens the door to new performance ceilings, longer operational windows, and machine-optimized decision-making. The emergence of the CH-7 introduces new dynamics into the Indo-Pacific aerospace landscape. With its long-range endurance, sleek aerodynamic shaping, and absence of a human crew, the CH-7 brings new possibilities for extended-duration missions that were previously difficult or costly for traditional aircraft. This creates significant implications for how regional forces plan, detect, and respond to advanced autonomous systems. One of the most impactful changes relates to reach. Because the CH-7's internal layout is optimized around fuel storage and equipment bays, without needing space for a pilot, it can potentially remain airborne for long periods at high altitude. Extended loiter capability increases coverage for missions such as high-resolution imaging, real-time environmental observation, and monitoring distant maritime regions. These features expand the CH-7's usefulness across vast oceanic spaces where traditional manned aircraft face endurance limitations. Its low-profile flying wing structure adds another layer of complexity. Shaping the aircraft to minimize radar reflections enhances its ability to operate in areas with advanced monitoring systems. This does not mean invisibility. It means reduced detectability, which forces other nations to rethink how they track high-altitude autonomous aircraft. This involves new radars, improved satellite sensing, and updated digital tracking tools. Beyond detection, the CH-7 sets expectations for what future autonomous aviation could look like. Advanced materials, refined computational fluid dynamics, and increasingly digital production pipelines all play roles in its development. These same technologies support China's advancements in 5th-generation and upcoming 6th-generation crewed aircraft. Skills gained from fabricating stealth coatings, composite outer skins, sensor fusion systems, and low-emission engines directly influence how the CH-7 evolves. For the broader Indo-Pacific region, the introduction of such a platform encourages new forms of collaboration. Neighboring states may begin investing in longer-range detection networks or forming multi-domain sensing partnerships. This creates ripple effects, not through confrontation, but through technological competition and rapid modernization. For aviation enthusiasts, this shift resembles developments seen in astronomy. Just as modern telescopes no longer require observers at the eyepiece, autonomous aircraft no longer require pilots in the cockpit. Machines can perform extended missions with higher consistency, fewer interruptions, and data-driven optimization. The CH-7's first flight marks a defining moment in autonomous aviation, revealing how quickly advanced unmanned systems are evolving. From its sleek design to its place within a larger strategic framework, the CH-7 demonstrates a new direction for long-range, high-endurance aircraft. As developments continue, this technology will likely inspire new systems, new ideas, and new conversations across the global aerospace community. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries, and don't forget to leave a comment below. Also, you can visit our website, SpaceEyeNews.com. Thank you for watching, and see you next time.